Hi everybody, my name is Kundan. Today I'll be presenting MongoDB, a non-SQL language, with my classmates Barbara, David, and Scene. Um, so MongoDB is a document database designed for ease of development and scaling. Let's start with introduction. So MongoDB is a scalable, high-performance, open-source, document-oriented database, which means MongoDB is generally used to store JSON objects. Like it could be documents, it could be arrays, it could be arrays of documents. So yeah, it's a database that is used to store objects and not strings or anything. So it is different from SQL. Rich document-based queries for easy readability. Uh, Full index support for high performance. So if we combine these 2 points, it means that MongoDB uses this index. So every row in MongoDB has an index attached to it. So this makes the searching of data easier, faster. Uh, Unlike SQL, it doesn't have any index. We can sort it out like however we want. Um, it's just the SQL, like SQL is just a bunch of data without an index, but this has a specific index and it has a specific pattern. Built for speed. So as I said, MongoDB uses index, so it is much faster than SQL or any other databases, as having an index makes us easier to navigate through the data. So it makes it easier to manipulate, view or delete the data. Easy scalability. So scalability, it means like uh, MongoDB separates data into smaller pieces. Like it's, I could say it's similar to divide and conquer, where you could just like divide the problem into smaller pieces and navigate your way through it in to both the pieces at the same time. So because of that as well, MongoDB is much more faster than other database languages. uh, Map reduce for aggregation. So if you remember from SQL you just join to combine two different tables, but MongoDB, it doesn't use join. They embed or they use references to connect two different tables. So it is so the time complexity for that is much lower than SQL for MongoDB to join data, or I should say to reference or to embed data. So why use MongoDB? So MongoDB is a NoSQL language that stores documents or objects. So of course it is different from what we have been learning in our SQL in our database class. SQL is used for like generally for strings, I guess, but strings and integers are those kind of data types. But MongoDB is used for documents, objects, JSON objects to be specific. It can be used to store arrays. Um, the major benefit of MongoDB is it complies with any programming languages. So um, yeah, MongoDB complies with Java, Python, Ruby, C. So uh, no matter what language you use, MongoDB is easier to connect with. Again, the other benefit is MongoDB does not use joins. It embeds documents and arrays to reduce the time complexity, and there is no necessity of joining it. Um, so that's why MongoDB is much more faster than other languages, database languages. Uh, so terms used in MongoDB. Uh, so in I have compared terms that we have used in our SQL class, and then what's the similar word for those terms in MongoDB. So for example, database in SQL means collection of objects in MongoDB. Again, table, what we know as table in SQL is known as collection in MongoDB. What we know as row or tuples in SQL is known as documents in MongoDB. What we know as columns or attributes in SQL is known as field in MongoDB. Uh, Moreover, so since this we don't use join in MongoDB, we use linking or embedding documents. What this means is like we use the reference of the other document in the document we are trying to link with. So I believe it reduces the time complexity by in such a way that we don't have to scan through every data in the other document. So that's why embedding document is much more easier and faster than joining data. Um, Also, a primary key. So in MongoDB, sorry, in SQL, primary key is user designated, but in SQL, there's a field known as underscore ID, which is the primary key for all the documents in MongoDB. So yeah. So how to install MongoDB? You have to download the MongoDB installer from this link here. The link is I have linked the um, URL here to installer, so you can check it out. It would download. You'd see an MSI file. You have to download that MSI file and run it. It would ask you to choose setup type. So you'd have two options, either complete setup and custom setup. Complete setup means that the installer would use the default options and install all the default tools and executables to install MongoDB into your computer, while custom means it allows you to choose the executables that you want to install. So this gives you custom gives you a kind of an option. What do you want to be specific with MongoDB? Um, then service configuration. So you'd see something like this when you're trying to install. Make sure that the run service as network service user is checked, and make sure that your directories are correct. And you'd need two directory. The first directory is for data, and the second directory is for logs. Um, you could keep that in the same place, but make sure it has like two different folders though, just because it's easier to navigate through, to differentiate, I guess. But yeah. Um, this installation method is for Windows users. It's similar for Mac users. It's not going to be very difficult for Mac users. Also, we also have provided uh, steps to install MongoDB uh, into the cloud. So it doesn't matter if you are Mac user or Windows user. We have these steps to install MongoDB on cloud. It's in the homework doc where we have all the questions. So yeah, take a look at that, and yeah, so that would help you to install MongoDB onto the cloud. And so it doesn't matter if you are a Windows or a Mac user. That should help you. Thank you.
Okay. My name is Sean Weimer. I am presenting the advantages of MongoDB compared to MySQL. So the first advantage of MongoDB is that there is no schema necessary. And what this means is MongoDB doesn't require like a set schema as in MySQL would. So in MySQL, usually we have to kind of create a table and put in each attribute for that table and kind of put the domain and everything that we want in there. And MongoDB has schemas that you can use, but does not require you to use a schema. So this is really helpful when we're collecting data from the internet, when we want to pull kind of unstructured data from something and put it into a database management system. If you tried to do that with a database like MySQL, it wouldn't really work because you would have all this unstructured data, and inputting that into something with no schema you're going to lose some data in the transaction. But if you had what you wanted in that schema, you would just keep that, but all the extra you wouldn't get. So an example of how this would work is, so MongoDB uses documents and instead of tables, as in MySQL. And so that allows you to input all this data into one document or multiple documents of whatever you want, and use that you can query data through those documents instead of using a normal query and grabbing rows or whatever you are looking for. And then the columns of MySQL, what we're used to in MongoDB, is called fields. And those are all contained within those documents. So that is kind of the advantage of having no schema. An example of this, so like I mentioned earlier, when we create a table in MySQL, as you can see here, we have create table publisher, we have the name, the varchar of 25, so we're setting the domain, the phone number, and then the city of the publisher. And so that's kind of our predefined schema of our publisher table in MySQL. And so here is like a normal insert statement that we would make of insert into publisher values. And you have the name here of Pearson, the phone number of Pearson, and the city of Pearson. And so that's a valid SQL statement that would work for what we're trying to do. And so as you can see here, if we were to do this in MongoDB, which granted, this isn't MongoDB syntax, this is just kind of a theoretical example of what we're trying to do and what you can do in MongoDB. So this is showing we have another insert statement. So if you were inserting a document or whatever, into publisher, we have the name again, same here. Phone number is the same. The city is the same. And then you can see here what's circled is 1884. So if we were trying to put in the year the publisher was founded, this would work in MongoDB. But if we wrote this exact insert statement for this MySQL table, it wouldn't work, right? We would get an error. So that's kind of, this is an example of just showing the benefit of that schemaless, kind of how MongoDB works. And a second advantage to MongoDB is that it uses horizontal scaling as compared to vertical scaling. And I think Kundan mentioned this earlier in the presentation, but it kind of, MongoDB uses more of the, he put it in like the divide and conquer way. So the horizontal scaling is basically when we have a bunch of servers and we divide and conquer throughout those servers. So you add multiple servers into your kind of database instead of like a MySQL database would use a vertical scale, also known as scaling up, which is where you would kind of increase the RAM or the CPU of the single server to take on all that all that power that you need through the relational database like MySQL, whereas the horizontal scaling you divide and conquer through each one of those servers. So in turn, that makes it a lot cheaper to use when you're not having to horizontal scale. And one benefit of horizontal scaling is when you would have a lot higher or a lot longer downtime vertical scaling than you would horizontal scaling, because if that one server that you're using goes down, obviously that's going to take a lot more time to reconfigure than say multiple servers, where if just one goes down and you have 50 other servers, you can use those 49 other servers and not really have as much of a downtime. And so another advantage is data insertion consistency. So basically, it kind of ties into what I was talking about earlier with the schema-less design. So you can load data in that has no structure, and you don't have to worry about losing any of that data. Like I said, when you store it into those documents, there's no predefined schema. So all of the data that you are pulling from wherever you're pulling it from is all going to be collected. None of it's going to be lost in when you load into that MongoDB. Whereas if you were to load into the MySQL, obviously if you had a value that wasn't in the predefined schema of your table, that value wouldn't go in and you'd get an error. And so an example of someone that this would be very beneficial to is an app developer. So say you build a new app and it's your first version and you want to pull a bunch of data, but you don't really know like what you're going to need yet. It would be beneficial to hold all of that data in a database like MongoDB, like a NoSQL database that you don't need a predefined structure, and you can grab all the data you want, store it in that. That way you're not losing anything that you don't need because you don't know exactly what you're going to want yet. And so you can go back and say, okay, I want this, this, and this. And then, like I said earlier, MongoDB you can use schemas if you'd like. So once you figure out the data you need, you can write, or you can have your schema for the exact data that you want, but you're not going to lose any from your initial like launch and then pulling the data from that. And so that's a big benefit for like an app developer with pulling data. And then the last advantage that I was going to talk about is change-friendly design. So most database management systems like a MySQL or any other SQL database management system, when you are going to update or add in new data, most of the time, this isn't for every relational database management system, but most database management systems will have a downtime for that. So when you are editing the data that is in your database, or if you grab new data and you want to load it in, usually there is going to be a downtime for that. And so one of the benefits of MongoDB is that when you edit this data or add new data, there isn't going to be any downtime. So that obviously you can see how that would help with if you had your MongoDB running in the background of your website and you're adding in new things, you're not going to have to not crash your website, but take your website down off the internet for X amount of time and reconfigure your data or add in new data. You can just do it on the fly and have no worry of kind of having any downtime or any of the like inserts or edits that you're doing. They're not going to interfere with any other operations that are going on. So yeah, that's 3 or 4 of the kind of big advantages of MongoDB. It's the no schema, the fact that we're horizontal scaling, the data insertion consistency, the lack of fear of, okay, I'm going to input all like millions of things of data and I'm not going to lose any of it, and the change-friendly design. So thank you.
Okay. Hello, this is David Greenwell, and I'm going to be talking about the disadvantages of NoSQL databases, specifically MongoDB, and the limitations of MongoDB. First, I'll start with some disadvantages. Um, as you know, and have you seen already, MongoDB does not support the join function like we've seen in MySQL. Um, but you have also seen that MongoDB is compatible with major programming languages such as Java or Python. Because of this, you could manually code a function with the same functionality as the join in MySQL, but this also may slow execution and affect performance. So this is the disadvantage. Next, we're going to talk about ACID compatibility a little bit. We talk about NoSQL databases. They do not support ACID. When we're talking about database transactions, ACID refers to the 4 key properties of a data transaction. A stands for atomicity. This means all changes to data are performed like a single function. In other words, it's all or nothing with the changes. Either all of the changes to the data are performed or none of the changes are performed. For example, in an application that transfers funds from one account to another, the atomicity property ensures that if a debit is made successfully from one account, the corresponding credit is made to the other account. The next property of ACID is consistency. This property is pretty straightforward. It means the data should always be in a consistent state when the transaction starts and when it ends. Going back to the previous example, the consistency property ensures that the total value of funds in both accounts is the same before and after the transaction. The next property is isolation, which means the intermediate state of a transaction is invisible to other transactions. Again, going back to the transfer of funds example, the isolation property ensures that a transaction sees the transferred funds in one account or the other, but not in both, nor in neither. Let's say that again. The isolation property ensures that a transaction sees the transferred funds in one account or the other, but not in both, nor in neither. And lastly, the D corresponds to durability, which means after a transaction is completed, changes to the data persist and are not undone, even in the case of system failure. For the fund example, the durability property ensures that the changes made to each account won't be reversed. So when you're thinking about choosing what types of databases you want to use, keep in mind that NoSQL databases, data validity is not guaranteed when errors, system failures, or other problems occur during your transactions. That being said, it is still possible for NoSQL technologies to be ACID compatible, but most are not inherently. MongoDB is ACID compatible at the document level, but it's not fully ACID compatible at the multi-document level, but they are very close to being it. MongoDB is probably one of the best NoSQL databases because it's trying to be completely ACID compatible, which is unlike any other NoSQL database. Okay, that was a lot about ACID compatibility. The next disadvantage is higher memory usage. MongoDB is a key value database, which means it associates data or values with a key, which is used to track whatever the data or the value is. Because of this and the lack of join functionality, there is data redundancy, which increases memory usage. This is somewhat solved with the horizontal scalability mentioned earlier, as horizontal scalability is cheaper. So, and then another disadvantage is that NoSQL is not compatible with standard query language. Since SQL is the standard language for relational database management systems, translating queries from SQL to MongoDB is hard. As far as simple query scenarios go, this isn't an issue, but as query scenarios become more complex, MongoDB's query complexity skyrockets with a lot more lines of code included in the queries. Going along with this, NoSQL databases are much newer than relational databases, so they're usually less stable and may provide less functionality. Also, because they are much newer, developers are still learning the ropes, and there's a lot less expertise when it comes to NoSQL databases. All right, we're finished with disadvantages. We're going to go and move on to MongoDB's limitations. When we talk about limitations, we of course have to start with document size. Document size limit on MongoDB is 16 megabytes. Since we're going to be talking about, or since we were just talking about data transactions, when we talk about MongoDB trying to implement multi-document transactions, 16 megabyte is the limit on document size. Also means that 16 megabyte is the limit on data changes in transactions. This is why I was saying that MongoDB is not fully ACID compatible yet, because there's still some limits. The next limit, the maximum document nesting level, is 100. So MongoDB supports no more than 100 levels of nesting for documents. The next limitation is the database name case sensitivity and restrictions. Since database names are case insensitive in MongoDB, database names cannot differ by only the case of a character. And also database names have some restrictions. They cannot contain // periods, spaces, quotes, or $signs. And the name also must be fewer than 64 characters, and it can be an empty name. Collection names also have the same restrictions. Next limitation, we'll talk about indices. A collection can have no more than 64 indices and no more than 32 fields in compound indices. There's also no limit on the number of documents in a collection unless it is a capped collection, in which the limit is for capped collection must be less than 2 to the 32 documents. Finally, we'll talk about the shard key limitations. The shard key has no limit on size. Shard key index cannot be an index that specifies a multi-key index, a text index, or a geospatial index on the shard key fields. Before MongoDB version 4.2, once you shard a collection, the selection of the shard key is immutable, i.e. you cannot select a different shard key for that collection. If you want to change a shard key, you must do a bunch of different stuff. The first thing, you must dump all the data from the MongoDB into an external format, dump it somewhere else. Then you have to drop the original shard collection. Then after that, you have to configure sharding using the new shard key. And then next, you gotta pre-split the shard key to ensure initial even distribution. And then lastly, you can restore the dumped data from MongoDB. And that is the disadvantages and limitations of MongoDB.
Hi everyone, I'm Barbara, and I'll discuss some of the use cases in industrial adoptions and why you should use MongoDB according to your needs. So first we'll start with the use cases. We have single view, Internet of Things, mobile, personalization, catalog, real-time analytics, content management, mainframe offloading, and gaming. You can read more of this in the MongoDB page. It's super well documented, and I think it's a good resource if you want to look at this more in depth. I'll discuss briefly all of this. First of all, we have single view, which basically refers to when you're trying to consolidate different data in different formats from different systems. If you're doing that in a relational database, it's hard, and in some cases, it's impossible. A single view application aggregates data from multiple sources into a central repository to create a single view of anything. MongoDB can incorporate any type of data, no matter what it looks like or where it comes from, while providing all the features needed to build a powerful application. For Internet of Things, we know that each new generation of a thing comes with new sensors, emitting unprecedented volumes of data, and provided new insights into the business. Building and operating IoT applications requires a data platform capable of ingesting massive volumes of sensor and event data with concurrent support for real-time analysis to flag anomalies and critical events as they happen. An event-driven architecture creates a data pipeline where event producers like devices and gateways in your IoT network generate a stream of events, and event consumers listen and react to those in almost real time. For mobile applications, I think MongoDB is great since new smartphones, wearable devices like an Apple Watch, and apps create new types of unstructured and semi-structured data. Relational databases can't easily handle the type of data you need to use to build good mobile apps. MongoDB flexible model and rich query functionality let teams build great apps, and it can manage any type of data. Then we have the personalization. Customer data is more than names and addresses. Now it includes browsing habits and social media profiles. So you can use MongoDB for all these features to personalize the customer experience, such as customized home pages, targeted offers, and social network sign-on. Then we have the catalog. A catalog stores lists of SKUs, trays, equipment, any asset or entity, as well as the associated metadata. MongoDB can incorporate any product, entity, attribute, or any other type of data. Also, we have the real-time analytics. We know that most companies use analytics nowadays. It's crucial. Many can act on data from months, weeks, or even days ago, but few can respond to changes minute by minute or second by second. Real-time analytical applications which provide lighter weight analytics very quickly. Latency is low and availability requirements are high. Then we have the content management, where data is more than text and pictures. Now it includes rich data types like tweets, videos, podcasts, animated GIFs, which are hard to store, especially if you're using a relational database. The structure of MongoDB is perfect to store all of this. Then we have the mainframe offloading. Many agencies will still oversee large environments consisting of mainframe hardware. The hardware is difficult and expensive to maintain, and it locks future development efforts into decade-old technology. With Mongo, you can offload key applications from the mainframe to a modern data platform without impacting your core system. And also the one I like the most is gaming, because I had never thought of this, but sometimes for games you need to unlock a new world, unlock new equipment, go to a different level. So modern games are multiplayer and online, and they can reach a massive scale, and they must evolve quickly to stay relevant. So the flexible document data model allows them to quickly iterate on what constitutes a player in the world, add and associate new features to player profile objects such as achievements, progression-based unlocks, and stuff like that. So after this, we have some industrial adoptions. The MongoDB page states that they are flexible enough to fit any industry. So here we have one for cryptocurrency, we have Sega for gaming, and we have the city of Chicago, which encompass very different fields. If you are familiar with cryptocurrency, you probably heard of Coinbase. The team scaled from 15,000 requests per minute to over 1.2 million requests, which is over 80 times the traffic during the height of cryptomania. It uses MongoDB to power systems of engagement, enabling all the user actions and events that occur during a typical user session. They also record and store user identities, account information, transactions, payment methods, and more. And the system also gives them insight, which is used to support and improve the overall customer experience. Also, we have Sega, which migrated to MongoDB Atlas to simplify operations and improve experience for millions of mobile gamers. Just as the gaming platforms have evolved and transformed through the years, so too has the database layer. It had to grow and adapt. The standard practice for launching these games involved load testing the servers to the point of breaking, then provisioning the resources to handle an acceptable failure point. This limited application functionality could cause service outages when reaching the provision resources breaking point. Also, this one is really interesting. The city of Chicago used MongoDB to create a smarter and safer city. One person, one laptop, and MongoDB's technology jump-started a project that, with other people joining in, went from a prototype to one of the nation's pioneering projects to analyze and act on municipal data. The project is called Windy Grid, and it is an intelligent operations platform built on MongoDB. It pulls together 7 million different pieces of data from city departments every day. And it creatively pairs MongoDB-powered analytics with visual maps, giving managers insight on city operations in real time as they unfold. So now we have when to use MongoDB. We have heard of the use cases and why it's so great to certain industries or products. So we have the rapid development. If you are an agile team and you need to move fast, MongoDB is right because the dynamic schemas let you iterate. The developers spend less time on the database and more time developing the app. Also, it's high availability since if you need to minimize the downtime caused by routine maintenance operations, which are planned, and some others that are not planned, like sudden system crashes, you should consider MongoDB. Also, if you have an unstable schema and the data you have is not as structured, like mentioned before, podcast GIFs, you have, or you don't really know if the data is gonna grow, you're gonna store more, you should use a NoSQL database. Also, if you don't have a database administrator, Mongo has the database capabilities that focus on agility with a dynamic schema instead of a fixed schema, and features that make operational management easier in areas like high availability and horizontal scaling. Finally, we have cloud computing, since if most of your services are cloud-based, like a lot of companies that are migrating to the cloud, Mongo is right, since it can be installed and run on any cloud provider or on-premise network as a self-managed database cluster or virtual machine. So you can use AWS, Google Cloud Services, Azure, and also using MongoDB Atlas, which I'll show you right now. Here I have my MongoDB Atlas cluster. It's called Mongo Tutorial. And if I go to collections, I can see the sample data I downloaded. We have the Airbnb sample, which is the one we're using in the homework, but we also have, for example, the weather data. And if we see this, we can play a little bit around with this and we can see how data is stored. This is an object, for example, this is an array. And we can also play with the queries, which we do in our homework. Also, here is the page I mentioned in the industrial approaches slide that has a lot of good companies using MongoDB, and you can, for example, click and read more and see how this database solved an issue for them and made their processes even more efficient. So I hope you enjoyed our little tutorial, and I hope it's useful. In the future, you can use MongoDB probably in a different project, a mobile app you want to work on, and hopefully all of this information will be very useful. Thank you.